Swayam Prabha. Digital India. Educated India.
Welcome back, dear learners, to this NPTEL course on low cost building materials and techniques. My name is Dr. Vishal Chettry and I am working as an assistant professor in the Department of Architecture, Planning and Design at IIT BHU Varanasi. I have been taking this course from past few weeks and we have covered different aspects related to low cost materials, and we have covered already the details on why low cost materials is required and how it adds up to the sustainability and overall cost effectiveness of construction. And with that intent, we have actually started with understanding about using earth as a building material, wherein we have already covered about different aspects of earth as a building material. Like we have understood different global applications of earth architecture. We have seen globally how earth has been used for construction since time immemorial, and also we have understood different components of earth, and then there are certain tests that has to be done to use or to effectively utilize it for the construction. So now let us also focus on understanding of about stabilizers, as I have been using this word again and again in my previous lectures. So now it is time for me to explain what by stabilizer I actually mean and how it is actually done. Along with that, we will understand about using earth as a construction material for different purposes, like for structural requirement or for different typologies of earth construction that is possible. So all these details will be covered in this presentation, wherein I will show you the detailed content and then we will figure out the details of each of the subtopics that are prepared for this lecture. So the content of this particular presentation will be a brief introduction about stabilization in the mud construction, because as I was explaining you before that when you use earth as a construction material, if the earth doesn't have certain quality in it, or as per the standards it doesn't meet the quality after you have done some test, which may be in field, which may be done at the field, that is where you have excavated the soil or the earth for construction, or you can do it in a particular laboratory where you can examine the properties of that particular sample and then determine whether it is usable or it has some defect, in the sense that some of the constituent materials are not present in it. So this all can be determined, and based on that the stabilization techniques as well as the required stabilizers may be added into the soil to make it more usable for earth construction. So we will cover the details about this in my this presentation. Also we will understand about need and objectives of soil stabilization. So why do we actually require soil or earth that is there on a particular site to make it to stabilize it and use it for construction? So what is that need? That will be we will be understanding about this. Along with that, we will understand about different types of stabilizers that are used for mud construction, which includes cementous stabilizers or natural or organic stabilizers, and a combination of both, which can be organic as well as some cementous stabilizers. Along with that, we will understand about the mechanism and effects of stabilization and some selection criteria for stabilizers and some techniques that are adopted for stabilization. With this, we will also understand about advantages limitation and practical consideration for the stabilization process. Then we will understand about types of mud construction techniques based on the structural requirement as well as the soil property. So, structural requirement here means that for what purpose are you actually using earth as a construction, whether it is for masonry or it is for load bearing or for some other typology of construction. So, that is what structural mean here. And with respect to soil property, so based on different types of soil that we see in different region, based on that we determine the type of earth construction that is possible. So, we will understand about this through some interesting chart and representation in the coming slides. With this we will conclude our presentation, and then some wrap up activities are suggested at the end of the lecture, and we will also showcase some of the topics that we will be covering in our next presentation. At the end we will show you some reference or that you can refer for more understanding on this topic. Now, let us recap quickly about what we had covered in the previous presentation. We had basically understood that earth or mud that we use for construction is one of the oldest and low cost as well as locally available building material. So, it is something which is not used or not started in use in recent times. So, I quoted some example in my last lecture that since Mohenjo-daro or since Harappan civilization or from Indus Valley civilization, we have seen how earth is used for construction. So, we have seen adobe blocks and similar other types of earth based material that has been used for construction. So, it has been used since time immemorial, and it is not that it represents something which is very weak in strength or which does not have that much of structural stability in it. So, it is contradictory to that. We can still find these masonry blocks are present till today. So, these are something which has been in use since many years, many millennium back, and they are still much popular here. Also, we learnt that how soil composition, specifically clay, silt, sand and gravel, have added importance to the balanced proportion for strength and workability. So, these are the constituent of any soil that we excavate or that we dig. So, how much percentage of clay, how much percentage of silt, sand or gravel has to be there in the sample, so that the workability or the ease of working with that material is increased, and it will lead to some better output at the end. So, that was also covered in the last lecture. Along with that, we have understood and explored some engineering properties of mud, such as plasticity, cohesion, compressive strength, permeability, which affects the overall performance of the earth construction. Then we also understood about different defects that occur in earth construction. So, what are the common defects? So, mostly we saw that it was cracks that were getting developed in the earth construction if there is no proper curing, or if there is fast drying of earth that is happening, earth construction that happens. So, with that the issue of cracks started to be developing on the surface. Along with that, erosion, if the walls are not protected, if you have constructed earth based the construction in some areas where there is plenty of rainfall throughout the year, and if you are not protecting that surface either from plinth or from roof, the wall, basically if it is not well protected, then there is a chance that the earth that has been used may erode very quickly, and then you may require regular maintenance of the structural member. Then next is shrinkage, if there is too much of clay content, and then there may be issues related to shrinkage that may occur, and then water sensitivity. So, these are some of the defects that has been observed in earth based construction, and some suggestions were also discussed on how to limit the impact of these defects in the earth construction. We also studied some very important soil test that is necessary to determine the quality of earth that is used for construction. So, that was also covered, and numerous examples were types of tests were suggested which can be done on site where the excavation is done, or it can be done in a particular laboratory by determining the constituent of the material or of the sample that you have collected from the site. Also, we examined some application criteria and construction practices like stabilization, plinth protection and roof overhangs, which improves the performance of earth based construction. So, this was all discussed in the previous presentation, and if you cannot or if you are unable to recall this, you may quickly go back and understand those details in the previous presentation and then come back to this particular presentation for understanding about this topic, because the learning from the previous presentation will help you in understanding about the topics that we will cover here in this slide in detail, in this presentation in detail, particularly related to stabilizers. So, now let us start with the content of this particular presentation. So, as I mentioned earlier, we will be discussing more on stabilization technique that is adopted for earth based construction. So, here stabilization means that it is a process of improving the energy engineering properties of soil by adding suitable materials like stabilizers. So, it is a process, it is a method by which we add certain material in the soil so that the quality or the property of the soil is improved. So, the material that we add in the soil is known as stabilizer, and the entire process is known as stabilization. So, this is the basic definition of stabilization and stabilizers. So, raw mud, that is the earth that we take out from a site or from a place, has if it has some limitations such as low strength and high water sensitivity, thus it makes stabilization necessary for construction. So, without that we cannot use that earth for construction, and if we use it without stabilization, then after some period of years we may face some defects that may occur on the surface of the wall, or it may compromise the entire structural stability or safety of the user, and then we may be saying after a period of time that earth based construction are not something which should be dependent on, and it is something which creates lot of problem, lot of defect and all that. So, all this is because of less information on the stabilization technique, or completely ignoring stabilization process for earth construction. So, that is where every material has to be tested. We have to know the property and composition of the material, only then we can determine how and what stabilizer has to be added in the earth, and then we can make something or we can design something which can last for at least 50-60 years without much of maintenance issues on the use of material. So, this is what the intent is, and with that intention we actually add stabilizer in the earth construction. So, stabilization also enhances the durability. Yes, of course, it increases the durability because it extends the duration or life of the material. So, it is possible to make an earth based construction durable for a certain period of year beyond 30-40 years, that we cannot see in case of bamboo. In bamboo also there is a requirement of preservation and treatment methods for its effective use, which may limit the impact of any insect attacking it or any termite attacking it. So, similarly here for earth based construction, to increase the lifespan or to increase the durability of the material, we have to do stabilization of the earth or the sample that we are using. It also increases the load bearing capacity and resistance to weathering. So, it actually increases the strength of the material to withstand weather, extreme weather, that is mostly like it is impacted by water or rainfall a lot. So, to make it more durable, so and to withstand this kind of climate extremes, stabilization process is required. Also, it increases the strength of the earth. So, earlier as you know that there is lot of porosity in or air gap in the earth, in the sample that you collect. So that is why compression is done. So all the air gap, or that air molecule that is present inside the earth sample, that has to be removed. So that is why compression, compressed stabilized earth block is manufactured and designed, and then they are used these days, and they are very popular in designing something which is very sustainable building. So likewise cement is added, so that all those porosity or all those air gap that are present, or it enhances the binding of the earth to a greater extent. So this is why these stabilizers are added, and it transforms the mud into a more reliable and standardized construction material suitable for wider applications. So we can increase the use of earth based construction for multiple purposes because of the use of stabilizers. Historically, the natural stabilizers like straw, lime and animal dung, that is mostly the cow dung, is used for is mixed with the mud, and then that is applied as a daub or as a plaster on the wall surface or even on the floor. In many of the rural areas, we have seen the use of these material, this commonly available material which acts as a stabilizer in the earth construction. So there may be some foul smell, but then you have to look into the percentage of these stabilizers that you add. So that is why a informed decision has to be taken, so that these issues that mostly is seen in such stabilizers can be avoided. And these days this type of material, the use of these materials has become very popular, especially in theme based restaurant where especially here in Varanasi there are few specific theme based restaurant where they try to put up or throw a life of village and exhibit it to the tourist that visit Varanasi. So it may be mostly the foreign tourist or the domestic tourist that they are actually shown a glimpse of village life in and around Varanasi. So similarly, it has been very popular in Rajasthan also. In Jaipur, I have seen some specific restaurants where, or some kind of a huge compound basically which has multiple eateries, and such kind of entire village setup is portrayed, and then these are quite popular places for tourists as well as for any visitor who would visit that city. So it is some kind of attraction that people would come and see, and then you can't say that that building is a low cost, and you can see how much attention it garners or how much revenue it generates just because that material that is used as a to reflect the village life. And these days village life is something which many people are fascinated about, and the earth is one of the popular material which comes into use when you have to showcase something which relates to village, because that is a common material that we see in village. So mostly in northern rural India. So you can imagine, earth is something which is not a low cost material. It's not just that stigma that is related to earth based construction is getting off from it as the day passes. So continuing ahead, so modern construction, especially earth based construction, incorporates cement, lime and chemical additives for better performance. So these are also added, and these are something which in a certain mix, and which doesn't hinders the sustainability of the project. Some very minimal percentage of these materials are mixed in the earth mixture to increase the strength and durability of the earth mixture. So this is why it is done. And then stabilized mud can also be used for walls, that is if you are constructing load bearing walls, so you can use them as for masonry, or even for design for constructing blocks, plasters, that is the daub that is applied on wattle or on the wall surface of the construction, and even on the pavement also. So these are some material that has been used for different purpose in earth based construction. Now let us understand what is the need and objectives of soil stabilization. So it basically increases the strength of the earth based construction. So you can see some technical aspect related to that how much of strength is increased and all that is mentioned here. Then it enhances the durability. Of course, it because once we have done the testing of earth sample, then we have identified what are the constituents that are lacking in the earth sample, and then certain stabilizers are added to increase the durability of the structure, because if you use that without stabilizers, then it will not withstand the duration that we have assumed for the project. Also the standardization, that is, it ensures consistent quality of modern construction practices is followed. So that is also the reason why stabilizers are added. The next is to reduce water absorption, that is, untreated soil may absorb 15 to 25% of water after the construction, so which can be reduced significantly if we add stabilizers in the earth construction. It also improves the workability, makes soil easier to mold and compact during the construction process. Further, it controls the shrinkage and cracking, that is, the cracks that develops on the surface. So it reduces them by at least 10 to 12%, which earlier used to be 10 to 12%, to somewhat less than 5% of such issues are observed. Also, it enables in diverse the use in diverse climates. So this is the major advantage of using stabilizers, or else stabilizers are restricted to the region where mostly it is hot and dry climatic region, to the use of earth based construction in hot and dry, because there the rainfall doesn't happen much, and then it is best to work with, because it cools the interior and tries to maintain a certain temperature, a comfortable temperature microclimate inside the structure. But if we have to use this in places where there is too much of rainfall, then the issue, especially in terms of workability and in terms of control in shrinkage and cracks, can be minimized if we add stabilizers in the earth construction. So these are certain reasons why we do stabilization. So next, let us understand about the different types of stabilizers that are used for earth construction or for mud construction. So first, that I had mentioned in the content also, it is cementous stabilizers. So these are stabilizers which works by forming cement like binding compound that significantly improves the strength and the durability of the soil. So that is the advantage of using cementous stabilizers. So the first example, the material that is used for cementous stabilizer is ordinary Portland cement, that is OPC. So the most common used stabilizers in mud construction, when mixed with soil, typically 5 to 10% by weight, it reacts with water through hydration, forming strong bonds between the soil particles. So that is the advantage of using OPC as a material. The next, it increases compressive strength up to 5 to 10 MPa and greatly improves resistance to water and erosion. So using this has added advantage with the earth based construction. Then next is the pozzolanic materials like fly ash and silica fume. So these are also used as a stabilizer. So industrial byproducts that react with lime in the presence of water to form cementous compounds. So fly ash is one among them, which is widely used because it is cost effective, and it also is adds sustainability to the project. It provides long term strength gain, and also it helps in reducing the carbon footprint compared to the pure cement use of the in the contemporary building. The next is cement lime, which is particularly effective for clay rich soils where there is too much of clay in the in the earth. You can use lime as a stabilizer. So it reacts chemically with clay minerals in a pozzolanic reactions, reducing plasticity and swelling. So the cracks that may develop, and then there is too much of plasticity, that is also not good. It will not dry very easily or quickly, and then the strength may not be as it becomes much brittle in nature if it has too much of clay content in it. So to reduce that impact, we can add lime in the earth mixture. So overall, these are some of the cementous stabilizers that can add to the to increase the workability or to increase the durability and strength of the earth based material. Then next is natural and organic stabilizers. So these are traditional and very eco-friendly, because these are all the byproducts of nature and it can disintegrate back to nature very easily. So, and these are eco-friendly, also derived from different natural sources. They are widely used in vernacular constructions due to their low cost and local availability. So these fibers act as reinforcement within the soil matrix. They improve tensile strength and ductility, which soil naturally lacks. It reduces the shrinkage cracks during that occurs mostly during drying by distributing the stress, typically added in small quantity, that is somewhere around 0.5 to 2% of the weight of the material. Common techniques that are used includes cob wall and adobe blocks. So there these plant based materials are added. So example that you can see are straw or coconut shells and all that leftover the coconut fibers may be added over there. Then next is animal byproducts, that is animal fat or any cow dung that is traditionally used in India and other regions. So cow dung improves binding, it reduces cracks and enhances surface finish. So animal fats or oils provide water repellent properties. So these were added, and if you see the different types of mortar that were developed earlier in many forts and palaces, you will find use of these materials and other organic materials like turmeric or even such daily used items to prepare some kind of special mortar which helps in better binding of material and also increases the strength of the construction. So these were used since many ages, and that is where now we have to reflect and go back and understand such traditional indigenous architecture and try to infer the key learnings from these architecture, because most of these practices are very sustainable and also they are very low cost in nature. Then next is bituminous material. So it includes natural or processed bitumen, acts as a waterproofing agent, the coating the soil particles. So it reduces water absorption by 50 to 70%, commonly used in plasters, foundations as well as in road construction. The next is the combination of stabilizers, that is the hybrid stabilization. In practice, around 2 or more stabilizers are often combined to achieve better performance, like we add cement and then fly ash together with the earth, which improves the strength and as well as it reduces the cost of construction. So next example is by mixing lime, soil and fiber, it balances the plasticity and also it reduces the cracks that are formed. The next is cement and fiber, so it improves both compressive and tensile strength of the construction. So other example are hybrid system can also optimize the performance, the strength of the material increases by 2 to 4 times, it also reduces the shrinkage and also improves the durability of the construction. So overall the selection of different materials or stabilizers depends on the soil type. As I was explaining, based on the test that you do, you have to determine which material is lacking and what advantage did that material provide in the earth that can be supplemented through the stabilizer. So it is some kind of supplement that can be added in the earth based construction to improve durability and also improve the improve overall quality of construction. So also now let us understand mechanism and effects of stabilization. So cement stabilization forms cementous bonds which increase the compressive strength. Lime stabilization causes pozzolanic reactions, thereby reducing the plasticity index, and then if we add bitumen, it coats the soil particle, making them waterproof and also reducing permeability. If we add fibers, that's natural fibers, it acts as reinforcement, thereby improving tensile strength as well as limiting the development of cracks on the surfaces. Next is about stabilization, that also reduces the permeability by about 50 to 70%. Improves load bearing capacity and resistance to erosion, enhances long term performance, allowing structures to last 50-100 years. Then it also overall the performance depends on selecting the right stabilizers and also the technique of the stabilization that is added. So these are the effects of stabilizers that is seen during the stabilization process. The selection criteria of these stabilizers and techniques mostly depend on the soil type, as I had explained earlier. Like if it is clay soil, you have to add lime; if it is sandy soil, you have to add cement based stabilization. Then again, about climate condition, this is again important parameter to be understood. High rainfall area requires water resistant stabilizers. So these are mentioned here. Apart from that, you can also let me know what are the specific stabilizers that apart from these two that can be added to improve improve the quality of construction in high rainfall areas. So next is about strength requirement. Load bearing walls need strength more than 3 to 5 MPa. So for that you may have to add some stabilizers. So let me know what are the stabilizers that you will add here in this to increase the strength. The next is about availability and cost. So local materials reduce the cost by 20 to 40%. So whichever local material that is available, you will add them as a stabilizer. So also here you have to name what are the locally available stabilizers that you will add to increase the quality of earth construction. The next is the construction technique specific. So if it is adobe block or rammed earth, so what different stabilizers will you add? The next is the environmental impact. So lime and natural stabilizers have low carbon footprint than cement. So it is better to use this and to avoid the use of cement to a certain extent as possible. The next skill level and technology. Advanced methods require trained labor and machinery. So you can avoid them by using some locally available stabilizers in the construction. So overall, let us understand the advantages. What advantages do stabilizers bring into the construction? So it improves the strength and durability. It reduces the maintenance frequency from 1 to 2 years to 5 to 10 years. So every 5 to 10 years there may be some small plastering or repair work that may be required, that we also do. In fact, in the modern construction, like for every alternate years we have to repaint the entire structure to as a yearly process. So similarly here that is done, and it should not be cause of worry in case of earth based construction. So it is better resistance to water and weathering, cost effective compared to concrete construction, eco friendly with reduced carbon emission. So these are the advantages that stabilizers bring into the earth based construction. Limitation is that it requires proper soil testing and mix design. So it requires some help of certain professional who will help you determine that what should be the ideal mix of earth based construction to use it for different purpose. So that is where it creates some hindrance, and it can be easily avoided through some skill development training programs that can be done at multiple levels. Next is cement stabilization increases carbon footprint and cost. So that is why we have to limit the use of cement in stabilization process. Also, no matter how much stabilization we do for earth construction, still is not good for constructing a high rise building. So over there, particularly if it is just the partition wall or just the cladding, all this can be done, but not as a structural member. Then it also requires skilled labor and supervision for stabilization process, or else your mixture may be completely out of proportion, and then certain damages or certain defects may occur very quickly in the construction. The other practical consideration that you have to keep in mind is ensure proper curing. This is must that we even do for concrete and for normal conventional brick wall. It provides plinth height, that is somewhere more than 300 mm to at least that should be provided, and roof overhang should be more than 600 mm to protect the wall surface. Also, regular inspection is required to prevent cracks and water ingress in the structure. So over here, let us understand the types of mud construction, especially in terms of structural requirement. So here monolithic structure is one of the category. Along with that you have masonry as well as load bearing structure. So these are the three different types of structural requirement based construction, wherein we can see some of the subtypes of earth based construction that is categorized under these three broad categories. So If it is a monolithic structure, so earth dug out, poured earth, stacked earth, direct shipping and rammed earth. These are different typologies of earth construction that is possible under monolithic structure. Similarly, for masonry structure, these are certain different types of earth based construction. And then for load bearing structure, these are the list of construction techniques which are particularly relevant for earth based construction under load bearing structure. So I hope you understand the difference between these three broad categories. Monolithic is something which is constructed at once, and masonry is something which is built block by block, that is you have to create blocks and then they are bonded together and then you get a wall or any structural member. If it is a load bearing, that means the entire load of structural load is transmitted through that particular member. So this is the basic definition of three categories, and in detail, particularly in the entire course, we will be discussing about rammed earth, compressed earth blocks and adobe blocks, as well as daub earth and the cob wall. So we will be covering these 4-5 categories in detail, because it is not possible for to discuss this entire typology in this 12 weeks course, because it has multiple other dimensions of earth low cost architecture or low cost building materials and techniques that can be covered. So I have just selected some of the prominent or some of the very common earth based construction that can be used in the practical projects also. And then also based on soil property, if the earth that is available in your site is too dry or very solid in nature, so then what type of construction is possible? It is basically dug out, cut blocks or filled in type of earth construction. If it is very humid, that is too much of the earth is available in a humid location, so over there filled in, covered, compressed blocks or rammed earth construction or shaped type of construction is possible. Then in areas where the soil clay content is very high, especially in Indo-Gangetic plains, the plasticity, because of high content of clay, the type of earth based construction that is possible is shaped, stacked, that is cob wall, and molded, that is adobe wall, and then extruded form of construction, that is mostly compressed stabilized block. Then next is the liquid, where there is too much of rainfall, and if your area is near the river or huge water body, so mostly that construction that is possible is daub, that is in case of wetland daub wall we need something very liquid, not such watery kind of earth, but something which is very very easy to just apply on the surface, because if this is the surface you have to apply, if it is a bamboo mat and then you have to apply earth over here, then it has to be something very kind of very sticky in nature, so that it can be applied very easily. So that is where liquid type of earth is much suitable here. So that is why daub kind of for daub such liquid soils may be preferred. Then formed, that is straw and clay, and then poured type of construction where it is done. So these are poured means mostly rammed earth construction where this process is adopted, because through ramming we can take out the excess liquid and then it can be left to dry over a period of time. So these are different construction techniques based on the soil property. Next, let us now summarize this entire learning so that we can understand more in the next lecture. So overall it can be summarized that soil stabilization is essential to transform weak, water sensitive mud and also mud into a durable and reliable construction material. Different types of stabilizers like cementous, natural or enzymatic or hybrid are based on the soil type that is available and also based on the performance requirement of the earth. So stabilization has significantly improves the strength, durability as well as the shrinkage that may happen with the water. The mechanism of stabilization involves binding soil particle, reducing porosity and improving the cohesion and compaction of earth based construction. Proper selection of stabilizers depends on soil properties, climate conditions, cost and the availability of the material that is there for the stabilizer. So overall stabilized mud construction offers a sustainable and cost effective as well as a scalable solution for modern low cost housing despite some practical limitations with the use of earth based construction. So these are some activities that are suggested which you can complete at the end of the lecture. And these are topics specially pertaining to contemporary innovations and sustainability aspect of earth construction that will be covered in detail in the next presentation. So, these are books, articles and documentaries which you can just quickly go through and check in the websites and understand more about these topics that have been covered in the presentation. So, with this I would like to thank you for your patience listening, and I hope to meet you in the next lecture. Thank you.